Hello everyone. This is what we call a lab extension. Basically that means that we're going to take the results that we found in our disc rolling down an incline lab, and then we are going to extend on that and build kind of a new math model. Now this one we're going to talk about how we're going to use the calculator to find slopes of tangent lines so that we can figure out if there are graphical and mathematical representations of the relationship between the velocity and the time for a disc rolling down an incline. We now know that that velocity is the slope of the tangent line to the position versus time graph. And so I'm going to show you here in a moment how we're going to figure that out using your TI calculator. You will eventually fill in a nice data table that looks like this. So notice you have your times that are the same times that you had in the original lab. And now we're going to figure out what your velocities are, your instantaneous velocities, if you want to be fancy, for each one of those times. In other words, the slope of the tangent line at each time. Now I highly suggest that as I go through this, you make liberal use of the pause button, because I'm going to very quickly kind of say what's going on, and then you can hit pause, play with your calculator, and then start it back up again when you're ready. So, here we go. Step 1. First thing you have to do on your TI calculator is to enter the position math model that we got out of your lab. Now, find your calculator that's on here, whether it's an 8384, an 86, or an 89. Probably most of you are in this first column here to the left. And all you have to do is hit one button, or maybe two. You should pop up a little screen that says y equals, and a place where you can type in an equation. So let's enter in that position math model we got out of the lab. If you have any other equations that are there, delete them, because otherwise they might get in the way. So we just want the one equation here to graph. So your equation looks something like this. I want you to type it in so that it looks like this. Okay, it'll say y equals on your calculator. Put your slope in, whatever that was, and then x squared. Make sure you get the squared in there. Otherwise it'll be a straight line instead of a parabola. So type in y equals your slope from the original lab, x squared. Now, if that's worked for you, the next step is we're going to change what's called the graph window so that when we try to graph that function, we see the part that we need for the lab. So again, find your calculator and hit these button or buttons. And then type in these ranges. Your x min, which is your minimum times, 0. Your x max, which is your maximum time, put 20 because that's a little bigger than our biggest time, and put in a scale of 0.1. Your y min, make it negative 20. Don't worry about the number here. It's just going to help to see it on the screen. Put in a y max of 150 and a y scale of 0.1. Again, hit pause if you need more time. Next, we're going to tell the calculator what we want it to do. It now knows our function. We want to tell it to find the slope of the tangent line at particular times on your graph. So find your calculator, and it's anywhere from 3 to 6 buttons depending on your calculator. After you hit these 3 buttons, say if you're on a TI 8384, you should see a graph of your math model, a nice top opening parabola with a blinking cursor in the middle of it. If that doesn't show up, you did something wrong in the previous parts and you might want to rewind and try again. Now that the calculator knows what you want it to do, find the slope of the tangent line, all you have to do is type in your lowest time, which would be 2 seconds. And so just type in a 2, and then hit enter. What should happen now is you should end up with a tangent line being drawn on your graph. Your calculator is actually taking a second point and moving it closer and closer and closer and closer together till it finds the tangent line, and then it's graphing that tangent line. It will then tell you, one of two ways, what the slope of your tangent line is. It'll either say this, dy over dx, which those of you in calc know is calc speak for slope of tangent line, right? And then a number, which is your slope of your tangent line. Or with an 8384, I think it gives you a y equals mx plus b equation, so you have to pull the slope out of that. That would be the one next to the x, right, is the slope, that number. And because this is a position time graph, that slope of your tangent line is your instantaneous velocity. Record it in your data table. Now you basically have to repeat this process for all your other times, 4, 6, 8, 10, 12, 14, 16, and 18 seconds. Each time you have to punch the 3 buttons or the 6 buttons in again, right? Then type in your new time, and then hit enter, and it will graph a new tangent line, and it will end up telling you what the slope of that tangent line is, which is your instantaneous velocity. Tomorrow when you come into class, you should have that data table finished, and we're going to come in and right away we're going to make a graph of velocity versus time in Logger Pro and see if there's a relationship.